Presently, researchers are hailing a significant discovery. Another planet, which they've called Proxima b. At only 4 light-years away, it's relatively close to us. It's approximately the same size as Earth and, because it's the perfect distance from its star, it may be the right temperature to have liquid water and potentially life. Looking beyond our solar system to the next nearest star, Proxima Centauri, we find that it's 24 trillion miles away. While that sounds far in space terms, it's our neighbor. The planet, known as Proxima b, is slightly larger than Earth. Despite its star being much cooler than our Sun, the planet lies in the habitable zone, meaning liquid water could exist on its surface, which, in theory, could support life. NASA has discovered a super-Earth that could also support life. This new exoplanet is 137 light-years away, or approximately 800 trillion miles. Cosmologists say the planet is about 1.5 times the size of Earth and orbits a small, reddish star cooler than our Sun. This is very exciting. While we haven't found an exact twin of Earth or a precise replica, this discovery is part of a collection of 500 new potential planets, slightly larger than Earth. How vast is the universe? Does it have a limit? Is Earth the only planet that can support life? And if life exists in the farthest reaches of the universe, what might it look like? To answer these questions, researchers are exploring the stars closest to our solar system. Proxima Centauri is particularly intriguing because, in 2016, a rocky planet was found in its habitable zone, displaying characteristics worth studying. Dear explorer, good morning. Today we will explore our neighboring planetary system, Proxima Centauri. Before departing to investigate this mysterious part of the universe, consider liking this video and subscribing to ensure you miss nothing. Thank you and have a pleasant journey. NASA's James Webb Space Telescope has barely begun its mission, yet the universe is already proving to be more mysterious and beautiful than humanity ever imagined. This is a groundbreaking discovery. The telescope, an extraordinary instrument, is uncovering phenomena we didn't anticipate and cannot yet explain. This means we must rethink our understanding of the universe. The JWST is so powerful that, with enough observation time, it could detect any galaxy that ever formed in the universe. Since ancient times, cosmologists have been studying the night sky, seeking new stars. It's a colossal task to identify and map them, made even more challenging because nothing in the universe is stationary. Contrary to common belief, galaxies, each containing billions of stars, are constantly rotating. Furthermore, the work of astronomers in the 1920s and 1930s revealed that the universe is continually expanding. Edwin Hubble discovered that distant galaxies are moving away from each other, a finding now known as Hubble's law. The discovery that the universe is in constant expansion raises significant questions about its size and structure. Current cosmological models suggest the universe extends 45 billion light-years from Earth, but what lies beyond this observable part remains unknown. Recent advances, such as the creation of the Cosmic Flows 4 map, have helped scientists measure the distance and velocity of 56,000 galaxies, providing unprecedented accuracy. Based on this research, the universe is estimated to be 13.8 billion years old, refining our understanding of the Big Bang. Our galaxy, the Milky Way, belongs to the Local Group, a cluster of over 50 galaxies spanning 7 million light-years. This group is part of a larger structure, the Local Supercluster, which is between 100 and 200 million light-years wide. In 2014, new discoveries expanded our perspective further. It turns out the Local Supercluster is part of an even larger structure called Laniakea, meaning immense heavens in Hawaiian. Laniakea encompasses 100,000 galaxies and stretches over 500 million light-years. The Milky Way, located far from its center, resides in what might be considered its cosmic suburbs. Given this immense scale, is Earth truly the only planet capable of supporting life? Many scientists hope that other habitable planets exist, particularly within our neighboring Proxima Centauri system. Though relatively close on the cosmic scale at 4.24 light-years away, this distance is still vast. To put it into perspective, Voyager 1, traveling at 61,000 kilometers per hour, would take 70,000 years to reach Proxima Centauri. Let us embark on a virtual journey to Proxima Centauri, leaving behind Earth, our Sun, and our solar system. Along the way we pass Mars, the red planet. Mars is a rocky planet with a mass about 1/10 that of Earth. Its surface appears red due to iron oxide or rust. Its polar ice caps shift with the seasons, and sublimation during spring creates atmospheric currents that trigger massive dust storms. Continuing past Mars, we enter the asteroid belt, home to millions of objects, including the dwarf planet Ceres. Beyond this lies Jupiter, the largest planet in our solar system. Jupiter, a gas giant primarily composed of hydrogen and helium, has a mass greater than all the other planets combined. Named after the Roman king of gods, it's a planet of storms and mysteries, still holding secrets for astronomers to uncover. The circular nature of its appearance isn't as smooth as one might expect. A wide, unpredictable band of dull material clouds its middle. This dim band is made out of residue, youthful stars, and a lot of gas. We can likewise observe, practically in line with the plane, two gatherings of rosy fibers that extend around 30,000 light-years from the core of the world for the first group and 65,000 light-years for the second. These fibers are genuine nurseries of youthful and warm stars. Although situated beyond the local group and being the fifth brightest galaxy in the sky, it extends over more than 10 times the apparent width of the Moon. It is a joy for amateur stargazers in the southern hemisphere or in the low northern latitudes. This uncommon structure, combined with strong radio emissions, suggests that a collision occurred between a smaller spiral system and Centaurus A, which, by its gravitational attraction, absorbed its smaller neighbor, leaving only this dusty band. This band contains more than 100 star-forming regions as evidence. According to astronomers, this cosmic collision has been processing for several 100 million years, offering us this remarkable spectacle. It even happens that this galaxy is considered a source of ultra-high-energy cosmic rays. In excess of 1,500 globular clusters accompany it, embellishing it with a limitless number of stars. Some of these stars are rich in metals and follow a rotational movement around the primary axis of the galaxy, while others, poorer in metals, do not. Their differing compositions suggest two distinct ages. Their distinct behaviors confirm the theory of a merger between two galaxies that came too close. Let's now examine another globular cluster in the Centaurus constellation. Rotating 180 degrees, we find Omega Centauri, recorded as NGC 5139. More than 10 million stars are packed into a region around 150 light-years in diameter. Its size makes it the largest, most massive, and brightest globular cluster in our Milky Way. Its mass is equivalent to around 5 million solar masses, making it nearly 10 times more massive than an average large globular cluster. It is almost as massive as a small galaxy. The first descriptions of this celestial object were mistaken due to its unusual characteristics, placing it in the category of stars. It was during the 1830s that Omega Centauri was recognized as an unusual globular cluster, thanks to the use of a large telescope. Although there are indeed 200 other globular clusters in our galaxy, Omega Centauri stands out. Its properties allow for speculation that it may be the remnant core of a dwarf galaxy that disintegrated upon contact with the Milky Way. This hypothesis is supported by the presence of diverse populations of stars. Some are 12 billion years old while others are much younger. Its central region contains so many stars that they are only 0.1 light-years apart. A black hole of intermediate mass is even thought to exist at its core. Furthermore, its rotational speed is much higher than that of typical globular clusters, likely giving it its flattened shape. Among the astounding objects located in Omega Centauri, one is found in the coldest known part of the universe, where the temperature is only -272 degrees Celsius, 1 degree above absolute zero or -457 degrees Fahrenheit. This is the Boomerang Nebula, also known as the bipolar Centaurus cloud or the Butterfly Nebula. It is located about 5,000 light-years from Earth and appears to be transitioning into a planetary nebula, a star at the end of its life losing mass. Over the last 1,500 years, this star has lost nearly 1.5 times the mass of the Sun. The gas ejected continues to expand outward at a speed of about 160 kilometers per second, 100 miles per second. Though its central portion appears hourglass-shaped from Earth, closer inspection reveals this to be an optical illusion. The gas clouds surrounding the Boomerang Nebula are, in fact, spherical. I like to accept that a type of life could exist, not on the day side, not to mention the clouded side, but in the boundary locale between these two zones. This livable zone, known as the Terminator Line or Strange Place, would be situated between the extremely warm side and the freezing side, where the temperature could support the presence of liquid water. However, as we have already seen, Proxima Centauri emits a lot of ultraviolet light and X-rays, several times more than what we receive from our sun on Earth. This makes the surface far from hospitable for life, but it doesn't rule out the possibility of subsurface life. A few years ago, an event shook the astronomical community. Between April and May 2019, researchers studying Proxima Centauri at the Parkes Observatory in Australia detected an odd radio transmission appearing to come from that region of space. What if, as some researchers believe, it was an extraterrestrial signal? This transmission, recorded as BLC-1, is still being studied to determine its origin. Could be background noise from space or even a terrestrial transmission. Nevertheless, its peculiar nature has yet to be fully explained, fueling the curiosity of many people. The view from this planet, with its twilight glow from a blazing star and the distant sight of another star system, is enough to inspire wonder, and perhaps even filmmakers. But is Proxima Centauri be the only planet in the system? For now, we can say that another planet orbits Proxima Centauri, a much larger planet but also much farther away. This is Proxima Centauri c, or simply Proxima c. Proxima c is approximately 1.5 astronomical units from its star, similar to the distance between Mars and the Sun. It is classified as a super-Earth or mini-Neptune type planet, orbiting at a distance of 225 million kilometers, 140 million miles, from its star. Its mass is about 6 times that of Earth, and its orbital period is 1,197 days. While its existence is widely accepted among scientists, its characteristics remain uncertain. Its observed brightness is much higher than expected for a super-Earth, which challenges astronomers. Scientists at Italy's National Institute for Astrophysics have proposed 2 explanations for this excess brightness. The first hypothesis suggests that Proxima c is surrounded by a system of ice rings, while the second proposes that it is enveloped by a massive cloud cover. Both phenomena could reflect light, explaining the planet's unusual luminosity. However, Proxima c, unlike Proxima b, is located far outside the habitable zone due to its great distance from its star. This makes it unlikely to sustain liquid water or life as we know it. Let's now turn our attention to Proxima Centauri itself, often referred to as Alpha Centauri c. Despite being invisible to the naked eye, Proxima Centauri is the closest star to our Sun, just over 4 light-years away. It is a red dwarf star of spectral type M5.5v, with a luminosity about 1/1000th that of the Sun. Approximately 85% of the energy it emits is in the invisible infrared spectrum. Its surface temperature is estimated to be over 2,700 degrees Celsius (4,892 degrees Fahrenheit), and its mass is only 1/10th that of the Sun, with a radius about 1/7th of the Sun's. Discovered in 1915, Proxima Centauri orbits the Alpha Centauri AB binary system approximately every 547,000 years. Its orbit is highly elliptical, ranging from 4,300 to 13,000 astronomical units, 0.2 light-years. Estimated to be about 4.85 billion years old, this star will likely outlive the Sun, remaining on the main sequence for over 1 trillion years due to its low mass. Proxima Centauri is also a flare star, meaning it experiences sudden increases in brightness due to convection processes in its core. These flares, along with massive ejections of plasma, can significantly affect the habitability of planets within its system. Despite these challenges, Proxima Centauri is known to have at least one planet in its habitable zone, Proxima Centauri b. Let's now explore Proxima Centauri b, the closest exoplanet to Earth. Its discovery in 2016 caused a stir in the astronomical community, as it confirmed Kepler's hypothesis that Earth-sized, potentially habitable planets orbiting M-type stars are common. Proxima b is located just 7.5 million kilometers, 4.5 million miles, from its star, much closer than Mercury is to the Sun. This proximity results in a short orbital period of only 11.2 days. Despite its closeness to its red dwarf star, Proxima b lies within the star's habitable zone, where temperatures may allow liquid water to exist. The planet's size is slightly larger than Earth's, with a radius 1.08 times that of Earth and a mass 1.27 times greater, classifying it as a super-Earth. However, life on Proxima b could face significant challenges. If tidally locked to its star, it would always show the same face to the star, creating a stark contrast between the day and night sides. Its atmosphere, if it exists, might be composed of nitrogen and carbon dioxide, potentially enabling a vast ocean to redistribute heat between the planet's day and night sides. But Proxima Centauri's intense stellar activity could pose a threat to surface life. The star emits stellar winds up to 2,000 times stronger than those on Earth, as well as frequent bursts of X-rays and ultraviolet radiation. Despite these challenges, it's tempting to imagine some form of life existing in this dynamic environment. Now, how do you envision a planet like Proxima b, orbiting a red dwarf and illuminated by 3 suns? Could it already harbor some form of life? Let's continue to explore this intriguing possibility. Not on the day side, not to mention the clouded side. Yet, in the boundary locale between these two zones, this tenable zone known as the endline or strange place, would be situated between the exceptionally warm side and the freezing side, where the temperature would lean toward the presence of water in the fluid state. Yet, as we have proactively seen, Proxima Centauri emanates a lot of bright light and X-rays, multiple times more than we receive from our Sun on Earth. This is far from positive for surface life, yet it doesn't preclude the chance of subsurface life. By the way, a fact shook the astronomical community a couple of years ago. For quite a long time, various researchers have been examining the sky for radio transmissions. Among April and May 2019, specialists considering Proxima Centauri in Australia at the Parkes Observatory received an odd radio transmission that appeared to come from that region of space. Imagine, what if it was, as certain analysts believe, an extraterrestrial transmission signal? This transmission, then recorded, is named BLC-1 and is still being studied to determine its origin. It might be a benign noise from space, not yet identified, or even a transmission whose explanation could be terrestrial. Yet, for all that, its peculiarity has not yet been resolved, which excites a lot of speculation. Still, the view from this planet, whose glow is a sunset on a bursting star with another star made of a brilliant pair not too far off, is enough to inspire dreams and offer beautiful inspirations to creators. But is it the only planet around Proxima Centauri? For the moment, we can say that another planet circles Proxima, a planet much larger than Proxima Centauri b, yet also much farther away. Let's discover Proxima Centauri c, or more simply, Proxima c. This exoplanet is approximately 1.5 astronomical units from its star, equivalent to the distance between Mars and the Sun. It is a super-Earth or small Neptune-type planet that advances at a distance of 225 million kilometers, 140 million miles, from its star. Its mass is about 6 times that of Earth, and its orbital period is 1,197 days. Although its presence is not in doubt among scientists, its characterization is not yet refined. Its brightness, much higher than it should be for a super-Earth, challenges astronomers from the National Institute of Astronomy in Italy. They have published an image of the candidate planet. The image gathered suggests a planet with much larger dimensions, at least 6 times the diameter of Jupiter. These dimensions indicate that Proxima c cannot be a terrestrial planet but would instead be a gas giant. However, astronomers do not rule out the possibility of a terrestrial planet to explain the excess brightness of this planet. Researchers propose 2 hypotheses. The planet might be surrounded by an arrangement of ice rings, or it could be covered by a large cloud cover. Both phenomena, capable of reflecting light, could explain why this super-Earth seems so luminous compared to its size. Whether it is a gas giant or a super-Earth, Proxima c, unlike Proxima b, is unfortunately located well outside the habitable zone. The impressive distance separating it from its star places it far from the conditions necessary to maintain liquid water and, therefore, life as we know it. At best, it falls into the category of a cold super-Earth, making life on this planet impossible due to a surface temperature estimated at only -233 degrees Celsius -387 degrees Fahrenheit. This configuration is particularly remarkable to researchers because a super-Earth so far from its star could challenge existing theories of planet formation. The discovery of these two planets orbiting Proxima Centauri, the closest star to our solar system, has only heightened astronomers' interest in studying this planetary system. Researchers utilize the Very Large Telescope of the European Southern Observatory in Chile. Although the planets themselves are hard to observe, they achieved this feat by observing the periodic movements of Proxima Centauri. A third planet circles the star. This new candidate, named Proxima Centauri d, would have a mass equivalent to a fourth of Earth's. It would be a tiny planet comparable to a mini-Earth, and possibly with rocky terrain. Its distance from the star would be only around 4 million kilometers, 2.5 million miles. However, like Proxima c, it is, unfortunately, not in the so-called habitable zone. This discovery, however, raises new hopes. Our stellar neighbor seems to harbor a fascinating number of new worlds. The likelihood that this star has a multi-planetary system simply by chance is almost zero. This implies that all stars in this same class, in particular red dwarfs, likely have their own planetary systems. Searching for any hint of life at the edge of the universe is, therefore, no longer science fiction but science at its core. Additionally, for researchers at the ALMA Observatory in Chile, this theory is supported by the presence of dust belts around Proxima Centauri. ALMA data reveal the presence of radiation from cold dust around the star. This dust, composed of leftover matter that has not formed into planets or other celestial objects, consists of rocky and icy particles of various sizes. These particles can range from the size of a grain of dust to, more rarely, asteroids several kilometers in diameter. This belt is located several hundred million kilometers away from the star, beyond the estimated distance of Proxima Centauri b, the potential habitable planet. The total mass of this belt is estimated to be about 1/100th of Earth's mass. Like the Kuiper belt on the edges of our solar system, this one is characterized by an extremely low temperature of about -230 degrees Celsius -382 degrees Fahrenheit. Another discovery, even more astounding, interests astronomers. A second belt might exist, much farther than the first. Many questions about the nature of this belt remain. What might this second belt, located at such a significant distance from the central star, be made of? Could it be part of a complex planetary system whose interactions have led to its formation? Scientists worldwide still have many mysteries to unravel, especially as technology continues to evolve. The discovery of Proxima Centauri's planetary system has undoubtedly inspired both science and imagination, raising the possibility that one of its planets might already harbor some form of life. Efforts like the Breakthrough Starshot project, initially supported by Stephen Hawking, exemplify humanity's commitment to exploring these distant worlds. Proxima Centauri's story is far from over. Who knows what secrets this fascinating star system still holds? Centauri, as the nearest planetary group to our Sun, will be the most accessible to our future space investigations. The interest that numerous astronomers have for it doesn't diminish, particularly since a complex planetary system could well be situated there. As you might have perceived, the interstellar journey you are making is a virtual excursion. No device has yet been able to approach such a distant system, let alone a person. However, a project is being developed. This ambitious venture, although considered fantastical at the time of its announcement, is expected to become practical in the coming decades, thanks to the hard work of many scientists. This is the Breakthrough Starshot project, which was announced on April 12, 2016, live on the Webb by English astrophysicist Stephen Hawking and Russian entrepreneur Yuri Milner. Seemed like something out of a science fiction film. The project, which initially had a private budget of $100 million, involves the launch of an armada of thousands of gram-scale robotic spacecraft, with a goal of reaching the Alpha Centauri system region. These nanochips will reach their destination propelled by an Earth-based light beam guided onto their sails. Thanks to a planned speed of around 20% of the speed of light, these nanocraft could arrive near Alpha Centauri in the 20 years following their launch. This targeted speed would be 1,000 times faster than that of the space probes currently traveling through our universe, such as Voyager 1 and Voyager 2. If this project, which faces numerous technological challenges, is realized, these nanocraft would be able to capture images of potential planets within this promising star system, Proxima Centauri. Imagine the vast amount of data that could be gathered. We could study, map, and analyze this region of space much more closely. And what if the data collected opened up a new path? A path to another habitable region of the universe? Such a long distance covered in such a short time seems impossible. Yet, divided into two distinct groups, some researchers are focusing on miniaturized spacecraft, while others are working on the laser transmitter. These scientists face challenges never before encountered. Numerous technological milestones must still be achieved to overcome the difficulties associated with this unprecedented space exploration. These challenges include the maneuverability and durability of the spacecraft, their energy source and battery life, data recovery, resistance to the laser's intense radiation, as well as to the interstellar environment, and many more. The construction of the spacecraft's nanoscale sails remains the central technological challenge of the project. The concept of a sail to propel a spacecraft isn't new. In 2010, the Japanese Space Agency used a solar sail for the launch of the Icaros probe, whose sail measured 14 meters, 45 feet, on each side. This probe could move for years in space. Its sail, thinner than a hair, was coated with photovoltaic cells and a special material sensitive to particles. Photons emitted by our sun struck the sail, applying radiative pressure that allowed it to advance in space. However, for the proposed mission, which involves an interstellar journey, solar energy, diminishing with distance from the sun, will quickly become insufficient. Thus, another solution was required. Replacing solar energy with a very powerful terrestrial laser beam was envisioned. The sail, propelled by a laser beam, must withstand the intense heat generated while being ultra-thin to carry the spacecraft to its destination. It must not tear or melt under the beam's force. To avoid this issue, which could jeopardize the project, engineers determined the ideal shape for the sail. Measuring about 3 meters 10 feet wide, the sail must balance depth and width to limit strain and reduce the risk of tearing. The sail will consist of ultra-thin layers of aluminum oxide and molybdenum disulfide, capable of collecting the radiative pressure exerted by the laser, which will fire a large number of photons at it. The more photons there are, the faster the propelled object will travel, but the more the sail must endure extreme temperatures. The Breakthrough Starshot project, beyond the hope of gathering extensive data on our neighboring planetary system, is above all a unifying endeavor. Within a few short decades, it's possible that one or more planets with signs of extraterrestrial life could be detected from afar through spectroscopy. Imagine the impact of such a discovery. It would undoubtedly fuel scientists' insatiable desire for exploration, as humanity continues to question the possibility of life beyond Earth. However, an unexpected event could challenge the project. On March 24, 2017, a team of American astrophysicists observed an extraordinary stellar flare on Proxima Centauri. This event increased the star's brightness 1,000-fold for about 10 seconds, followed by a less intense flash. The record-setting flare lasted less than 2 minutes but was significantly more powerful than any previously observed. It is likely that during this flare, Proxima b, a planet orbiting Proxima Centauri, was bombarded by high-energy radiation. If such flares occur regularly, they might render Proxima b uninhabitable. Over billions of years, such flares could have stripped the planet of its atmosphere, evaporated its oceans, and sterilized its surface. While planets within the habitable zones of M-class red dwarfs like Proxima Centauri seem promising, their star's flares challenge the viability of life. Could life truly thrive on a planet orbiting so close to an M-dwarf? As our interstellar journey concludes, the next time you gaze into the vast night sky, you may see it differently. This mission has given you a glimpse into the heart of the universe and the marvels it holds. Yet many questions remain unanswered, even within the scientific community. Despite ever-increasing technological advancements, mysteries persist. New discoveries either confirm existing theories or challenge past conclusions, inevitably leading to more questions. Science's progress is relentless, and the desire to conquer space could one day become reality, thanks to the tireless work of researchers. What about you? Would you one day embark on an interstellar journey aboard a spaceship, traveling through the universe in search of a new world?